More things in the universe you can measure, and there's no limit to it. Every year when we get lasers better and better, we'll be able to see further out into the universe and see tinier things in the microscopic nature of reality, matter, space and time, anything like that.
Congress was told it was only noise, yet the numbers said otherwise. A faint object beyond the moon brightened right after we pinged it, nudged its path when our transmitters spoke, and warmed a few minutes later. There was no beacon and no greeting. There was only behavior that matched our actions as if it could read the schedule on our wall. Tonight you get the plan that proves this right or proves it wrong, the tests anyone can check, and the calm path that keeps planes and satellites steady while we watch. The first pattern. Awareness does not need words. It can hide inside timing and repetition. The first flag came from light.
This is the holy grail of physics.
Each time, Earth-based radar arrays were scheduled to sweep a patch of sky, photometry from several observatories recorded a small but steady rise in brightness on the same target. The spike arrived within minutes of the posted window and returned on different nights. Analysts tried to erase it. They checked clocks, replaced software pipelines, and kept observers blind to the radar schedule to prevent bias. The rise still came when the pings went out, and it stayed flat when the arrays were quiet. That was the first thread. Drift came next. Trajectory teams subtracted gravity, sunlight pressure, and thermal re-emission from the motion. A thin residual remained. It leaned the path toward lines of sight that favored planet overflights and better viewing geometry. The change was tiny, yet it refused to vanish as data improved. It appeared on clear nights and cloudy nights, and it survived new code and fresh calibration. Then came heat. Mid-infrared sensors saw temperature climb a little after our loudest calls. The delay was measured in minutes. The curve was smooth. The sequence repeated across nights. No single curve proves intelligence. Together they demand a test that strangers can repeat. The team set a simple rule. Do not chase spectacle. Chase repetition. If 3 independent instruments record the same change right after a pre-announced action, and if the change fades when we fall silent, we have a signal that deserves policy attention. Everything else is noise. That rule kept the work clean and kept the story honest. Here is the hook that matters. If this were your lab, would you keep the transmitters talking, or would you force the sky to earn your next step? Why? Congress stepped in. 2 facts pulled the story out of a research corner and into a secure room. First, the anomaly did not die when better calibration arrived, when different teams touched the files, or when the weather improved. It stayed. It persisted through weeks of observation, and it showed up in data from partners who did not share hardware or software. Second, the circle of interest widened at once. NASA brought optical light curves and infrared heat plots. The Space Force delivered precise ephemerides and radar logs. The Defense Department flagged timing overlaps for transmitters and deep space assets. The Federal Aviation Administration sent observers because timing errors can move routes.
We can run the videotape backwards and then calculate when it all came from a cosmic explosion.
Even ocean and weather agencies listened because global networks share clocks and bands. There was also a window that would not stay open for long. The geometry that let us record light, motion, and heat together would close when the object dropped behind the sun. That meant tests had to be planned, published, and run on schedule. It also meant some details had to stay quiet until pulses were finished, so curiosity did not create false signals. The rule was plain. Publish test plans in advance. Keep microphones quiet outside those plans. Mirror every raw stream into a ledger as soon as security allowed, so outsiders could check the math. The tone stayed calm inside the room. Members asked what could touch daily life first. They heard about timing jitters that might nudge airline routes, about link budgets that might sag on the edge of capacity, and about drag models that might need new terms if outgassing near-Earth orbit shifted baselines. None of that is panic material. All of it is planning material. The final slide carried one sentence in large type. Do not improvise. Hold to the schedule. Share the logs. If the pattern vanishes, say so. If it strengthens, you will see why policy moves. Does that sound like secrecy, or does it sound like discipline? The awareness index and the first 4 tests. People wanted a way to follow the work without rumors or leaks. The answer was a score that anyone could compute from public data. 5 parts add up to a simple number. First, brightness that lines up with radar windows. Second, residual acceleration after known forces are removed. Third, phase angle outliers when the object glows brighter or dimmer than geometry predicts during watch windows. Fourth, spectral toggles that shift when high-power transmitters are active. Fifth, repeatability across independent sensors on the same day. If 2 or more climb together week after week, the score rises. When the score rises in public, policy begins to pay attention. Would you ignore a score that your own plot confirms? Test 1 is pre-registration. Radar teams publish pulse times and power levels before a night of observing. Optical and infrared teams watch brightness and heat during those exact windows. If curves rise within minutes of the posted pulses, the correlation is out in the open, and anyone can check it. Test 2 is on and off illumination. Transmitters run a simple pattern for 10 minutes on and 20 minutes off across a full night. If the heat curve tracks that pattern with a steady delay, we are looking at feedback, not wishful thinking. Test 3 is geometry stress. Large Monte Carlo suites simulate millions of random trajectories under pure physics. If the observed path produces more planet overflights than the random set, and does so with a habitability weight that beats chance, intent gets a number rather than an adjective. Test 4 is a multi-band cross-check. Every candidate event must appear in optical, infrared, and radar within tight time windows. One telescope can make a mistake. 3 independent systems agreeing within hours is confirmation that survives hard questions. None of this needs belief. It needs patience, precision, and transparency. It also needs quiet.
Perfect pitch, but it's a choir of something like 1,000,000 trillion people singing at the same time, the same tone.
Amateur groups were asked to avoid unscheduled transmissions that could confuse the record. They were invited to mirror the data, build their own plots, and challenge every claim in public. A skeptical red team received funding to try to spoof the patterns with ground-based tricks, to hunt for pipeline bias, and to invent natural explanations the main teams might have missed. If the red team succeeds, the public will see how and why. If it fails, the score means more. Would you rather be dazzled, or would you rather be sure? If you value clear answers more than loud claims, click like and subscribe now so you receive the weekly index and raw links the moment they post. How nature fakes intention and how we strip it away. Space can mimic design with ease. Frozen gases vent on one side and act like tiny thrusters. That is asymmetric outgassing, and it can push a body just enough to look like steering. Spin-state resonances can line up a rotation period with our viewing cycle and trick us into seeing timing that we created with our own schedule. Dust can form tails that point toward the sun.
Axis stays in the same direction as it goes around the sun, produces the seasons, but regular seasons,
rather than away, and can imitate propulsion at a glance. Radiation pressure and thermal re-emission can nudge paths in directions that feel personal even when they are not. Instrument crosstalk can hide inside rare corners of a pipeline and create echoes that ride on honest curves. Nature wears many masks. Analysts use a 2-gate model to keep their footing. Gate A is physics. Remove radiation pressure, solar torque, spin coupling, dust forces, asymmetric outgassing, and known instrument biases. Only the residual that refuses to die moves on. Gate B is correlation. Demand that independent sensors in different bands record the same event within narrow tolerances. If only one instrument sees it, it does not count. When both gates close, you have an event worth escalation. This is how you keep a cool head when a story begs you to hurry. The strongest single tool is the thermal regulator test. Passive ices warm and cool as the light angle changes. They do not hold steady plateaus for long stretches. Electronics like stable temperatures. Radiators sit on narrow steps for many minutes because circuits prefer a set point. If you track mid-infrared output across changing geometry and see flat intervals that repeat, you have evidence of regulation. Add a second pattern and it sharpens further. One plateau appears when transmitters are active, and a lower plateau appears when they are quiet. That looks like duty cycled electronics dumping heat. Nature can mimic thrust. Nature struggles to mimic thermostats. There is also a way to measure trajectory intent with numbers rather than adjectives. Simulate millions of random paths with realistic speeds, approach angles, and solar forces. Count how often they produce the exact sequence of multi-planet overflights within the observed distance thresholds. Weight each pass by a simple habitability index with Earth highest, Mars and Venus lower, and the gas giants lowest. Compute a composite probability for the observed sequence and compare it to the random set. Report a score on a scale from 0 to 1 with error bars. Then shuffle observation times as a sanity check. If shuffling collapses the score toward chance, the original pattern holds more weight. If it does not, you return to gate A. Is that the kind of math you want guiding the next step? Operations, risk, and the ladder we climb. If awareness is real, the first effects will be mild, yet they will be real inside the systems that keep the world on time.
And what is awareness? Knows what you're thinking, feeling, doing, seeing, hearing. That's all.
Positioning networks could show tiny timing jitters when high power emissions overlap with deep space readings. A fraction of a second in satellite time can force airlines to adjust routes and launch teams to wait for a cleaner minute. Satellite links can lose margin if unexpected noise falls on shared bands and forces operators to boost power or reduce data rates. Atmospheric drag models can wobble if outgassing or pressure fields near Earth orbit shift baselines that debris tracking relies on. Power grids that depend on satellite timing could see phase errors that planners must smooth. That is why there is a response ladder. Level 1 is passive. Extend telescope time, keep sensors on, and build a longer record. Level 2 is controlled testing. Run transmitters in fixed patterns that are published in advance and log every variable. If the object responds the same way twice, the confidence score rises. Level 3 is temporary quiet. Reduce or pause high-power signals in selected bands to see if correlations fade, while navigation and emergency services remain protected. If nothing changes, the effect is environmental. If it weakens, the hypothesis gains support. Level 4 is orbital deconfliction. Adjust the paths of crewed or high-value satellites to avoid potential interaction zones while the tests run. There is no drama here. There are only prudent maneuvers and clear notices to operators. Level 5 is international coordination. If all signs still point to responsive behavior, the matter moves to a joint science panel that sets shared thresholds for any next step and writes the public script in plain language. Good policy favors patience, shared files, and precise words. It never favors whispers and sudden moves. Alongside the ladder lives a doctrine that spreads because it works. Contact minimalism. Observe without provoking. Replicate before reacting. Pre-register every test so the record stands on its own. Forbid unilateral messaging. The point is not fear. The point is control. Curiosity without coordination turns clean tests into muddy anecdotes. This doctrine shapes public communication as well. Say what you know, what you do not, and what you will test next. Invite outside replication. Fund a standing surge budget for sensor time because short windows expire. Restraint and openness live in the same plan. Would you trust any other approach with planes in the air and crews in orbit? The window, the data, and your role. The observing window is not generous. The geometry that lets us see light, motion, and heat together when the object slips behind the sun from our point of view. That is why the schedule is dense, and why the rules are strict. Publish test plans. Keep microphones quiet outside those plans. Mirror every raw stream into a public log as soon as security allows. Let universities, foreign observatories, and skilled amateurs chew the numbers in parallel. The fastest way to lose truth is to hide it. The fastest way to win trust is to share it. The mid-infrared test runs first because heat is hard to fake. If the curve follows sunlight, the story returns to normal science, and we retire the claim with real relief. If the curve holds steady plateaus through changing angles, tension rises because thermostats are difficult to explain with natural ices. The on and off illumination test runs next and repeats across several nights. If the heat lags match the schedule, the index climbs. The multiband crosscheck runs without pause, so that no single instrument can carry the weight of a claim. The red team tries to break every step. That is their job, and the public will see their papers. NASA, the Space Force, and partners abroad are aligning formats so every photon and ping enters the ledger with the same stamps. That sounds dull. It is the foundation for every claim that follows. Congress asked for weekly public metrics, not headlines. The dashboard will show the awareness index, the energy readings, the counts of raw observations, and the uptime of instruments. It will link to raw files, so outside teams can test their own filters and either confirm or challenge each step. The goal is not to win an argument. The goal is to trap reality in numbers that anyone can check. When the briefing ended, funding for sensor time moved to the top of the list, and data standards became a shared promise. No improvisation and no sudden transmissions. Every move must be logged, measured, and repeatable. That is how you protect crews in orbit and keep planes on course while you study a hard puzzle with care. Ask yourself one plain question before the next chapter. Do you want a show, or do you want an answer that the world can verify? If the patterns fade, if the patterns hold. There are two honest endings, and both of them are useful. If the patterns fade, we learn that nature can wear a mask that looks like intent when schedules and geometry line up just right. The thermal plateaus sink back into sloped curves that follow sunlight. The brightness stops tracking our radar windows. The residual drift folds into noise once models gain new terms. The awareness index falls towards zero, and the red team publishes a clear recipe that explains every odd turn. The files stay public. The code stays public, and everyone sees how strong method caught a mirage. That is a good ending because it hardens our tools and teaches humility without scaring the world. If the patterns hold, the world does not end. The world grows more careful and more curious at the same time. Mid-infrared curves sit on narrow steps through changing angles. Heat lags match our on and off schedules to the minute. Brightness rises inside the posted radar windows and rests when the transmitters rest. Multiband checks agree within tight tolerances. The intent score climbs as simulations fail to reproduce the real path across planet overflights. Agencies move up the ladder without drama. Passive observation expands. Controlled tests continue. Temporary quieting protects key bands. Orbital lanes get a little wider during the windows. The tone in the room stays calm because the playbook is working. Daily life adapts in small ways, long before it changes in large ones. Airlines adjust routes during test windows and explain why in simple notes. Power operators widen timing buffers on days when link budgets look thin. Satellite builders design for more margin around protected bands. News desks learn to treat the dashboard like weather. The public watches the score rise and fall and begins to see science as a habit rather than a headline. If we ever cross a threshold where communication becomes a real choice, it will not happen in a rush. It will happen with a mandate that spans borders, with every log pre-announced, and with every result mirrored for audit. No single voice will decide. The whole framework will decide. At that point, the doctrine keeps us steady. Observe first, replicate second, test third. Speak in simple words. No sudden messages and no improvised beacons. If communication ever becomes an option, it will use a charter that the world can read, with ethics that match the risk, and with engineers who can walk the public through every line. Until then, the most advanced tool we own is restraint. It sounds dull to some ears. It is how we stay safe while we learn. Here is the hook that closes the circle. Do you want answers that feel good for a night? Or do you want evidence that stands when your grandchildren ask how this began? This is not a story about fear. It is a story about discipline in the face of a rare chance to learn something real. We have numbers that line up across systems and a plan that can turn alignment into proof or into a clean refutation. If the object only mirrors sunlight, the curves will fall back into ordinary shapes, and the lesson will be about how quickly coincidence can fool good people, and how quickly good process can fix the record. If the plateaus hold, if the lags track our schedules, and if the path keeps beating chance, policy will move with care to protect what matters while we study what we do not yet understand. What makes this moment different is not a rumor. It is the method, pre-registered tests, open ledgers, aligned formats, a red team that is paid to break the claim if it can, a ladder that never steps ahead of the evidence. That is how you keep reason ahead of fear. That is how you keep the lights on while you look for truth. The object may be rock that fooled us, or it may be the first measured case of technology answering technology across a cold distance. We will not pick the answer by mood. We will let the numbers pick it in public with clear logs and clear words. That is the promise Congress heard. That is the promise you can hold us to as the next windows open. If you want the weekly awareness index and the raw links the moment they post, subscribe now and turn on notifications. Share this with someone who wants evidence over noise. Stay curious and stay calm. Evidence first, always.